The wind never truly stops in northern Greenland. It sweeps across endless fields of snow, carving sharp ridges into the ice and erasing almost every trace of anything that dares to cross its surface. For thousands of years, this frozen wilderness has acted like a giant vault, preserving secrets beneath layers of ice thicker than entire cities are tall. Most expeditions come here searching for ancient climate records trapped inside ice cores. They expect to find tiny air bubbles, volcanic ash, or traces of prehistoric pollen. No one expects to uncover something that seems completely out of place. Everything begins when an international team of glaciologists drills deeper than any previous expedition at a remote section of the ice sheet. Their objective is simple: collect a continuous ice core that may reveal how Earth's climate changed at the end of the last ice age. Day after day, the drill disappears into the glacier while researchers carefully catalog every meter that reaches the surface. The work is repetitive, slow, and often interrupted by brutal storms. Then, late one evening, the drill suddenly stops. At first, the engineers assume it has struck solid bedrock. That happens occasionally in deep drilling operations. But when they retrieve the drill, something unusual catches everyone's attention. Mixed with the ice is a dark fragment unlike any rock normally found beneath a glacier. It is smooth, slightly flexible, and covered by an intricate pattern of microscopic ridges. No one at the camp can identify it. The fragment is immediately sealed inside sterile containers and transported to a temporary laboratory. Under a microscope, the mystery only deepens. The surface appears biological, yet it matches no known plant, fungus, or animal tissue. Even stranger, tiny structures inside the material seem almost perfectly preserved despite being buried beneath ice for approximately 12,000 years. Carbon dating confirms the surrounding organic sediments formed near the end of the last ice age. The object itself, however, refuses to cooperate. Some tests suggest biological origins, others indicate mineral properties that should not exist in living tissue. Every new analysis creates more questions than answers. Word of the discovery spreads quickly through the scientific community. Laboratories across Europe, North America, and Asia request small samples for independent examination. Within weeks, experts from completely different fields become involved. Paleontologists compare it to extinct organisms. Microbiologists search for cellular structures. Geologists examine whether unusual pressure inside glaciers could have created an unknown mineral formation. The first surprising result comes from high-resolution imaging. Hidden beneath the outer surface lies an incredibly organized internal network. At first glance, it resembles blood vessels or plant fibers. But the pattern is mathematically precise, repeating itself with remarkable consistency throughout the sample. Natural biological systems rarely display such perfect symmetry. Then another unexpected discovery changes the direction of the investigation. Researchers detect complex organic molecules that resemble proteins but do not match any known species in existing genetic databases. Normally, even extinct organisms share recognizable molecular similarities with modern life. This sample appears fundamentally different. It is not completely alien to Earth biology, yet it refuses to fit anywhere within the established evolutionary tree. Speculation begins spreading far beyond scientific journals. Some people claim the object is evidence of an unknown ice age organism. Others suggest contamination from modern equipment. More imaginative theories appear online almost immediately, proposing everything from lost civilizations to extraterrestrial origins. The research team ignores the growing media frenzy and focuses on the evidence. Science has taught them that extraordinary discoveries usually have surprisingly ordinary explanations, yet as months pass, that explanation remains frustratingly out of reach. Meanwhile, glaciologists return to the drilling site for another season. Their goal is no longer climate research alone. They want to determine whether the mysterious fragment was unique or part of something larger still hidden beneath the ancient ice. As the drill descends once again into the frozen darkness, no one can predict whether the first discovery was an isolated curiosity or merely the beginning of a mystery buried beneath the ice for 12,000 years. The second expedition arrives during the brief Arctic summer, when the sun never fully sets and the ice reflects a pale golden light throughout the entire day. This time, the mission is very different. Every step is documented, every sample is collected under sterile conditions, and dozens of cameras record the drilling operation from beginning to end. The scientists know that if another unusual specimen appears, every detail must be beyond question. After months of debate surrounding the first fragment, there can be no room for doubt. For several days, the drill passes through nothing but ancient layers of compressed snow and crystal clear ice. Each section tells the story of a different era, preserving microscopic traces of volcanic eruptions, ancient dust storms, and long forgotten changes in Earth's atmosphere. Then, without warning, the drilling speed suddenly changes. The resistance becomes softer, almost as if the drill has entered a pocket hidden inside the glacier. When the core reaches the surface, silence spreads across the camp. Instead of solid blue ice, a narrow section contains frozen sediment mixed with dozens of dark fragments almost identical to the first discovery. They are scattered throughout the sample rather than concentrated in one place, suggesting they were deposited long before the glacier sealed them beneath thousands of years of ice. More importantly, they appear connected to something larger that extends beyond the narrow cylinder removed by the drill. Ground-penetrating radar is immediately deployed around the drilling site. The first scans reveal an irregular structure buried deep beneath the ice. It is too organized to resemble ordinary bedrock, yet far too distorted to identify with certainty. Some researchers suggest it could simply be an ancient landslide frozen beneath the glacier. Others notice repeating geometric reflections that natural rock formations rarely produce. No one is willing to make extraordinary claims. Instead, a robotic probe is lowered through the freshly drilled shaft, carrying high-resolution cameras and powerful lights. As it descends into the darkness, everyone gathers around a small monitor inside the control tent. At first, the camera shows nothing except smooth ice walls slowly sliding past the lens. Then the light catches something unexpected. Embedded within the frozen sediment are hundreds of thin, branching structures stretching in every direction. They resemble the roots of an enormous tree, except they are completely unlike any plant ever discovered. Their surfaces display the same microscopic ridges found on the original fragment, and every branch divides according to an almost perfectly repeating mathematical pattern. The images immediately raise another question. If this truly is biological, how could an organism survive in one of the coldest environments on Earth? Geological records indicate the region was already experiencing severe glacial conditions. Even the hardiest known organisms require at least occasional access to liquid water. Laboratories around the world begin comparing the branching structure. Nothing matches. Paleobotanists rule out ancient forests. Marine biologists find no similarities to deep-sea organisms. Even fungal specialists admit they have never encountered anything remotely comparable. Then comes the most surprising discovery of all. Using advanced chemical imaging, researchers identify traces of pigments buried inside the structure. Under normal circumstances, pigments slowly break down over thousands of years. These molecules remain astonishingly intact. More importantly, their chemical composition suggests they once interacted with sunlight. That finding changes the entire investigation. If the organism depended on light, it could not have lived deep beneath the glacier. It must have existed before the ice expanded across the region, preserving it almost instantly as temperatures fell. Climate scientists begin re-examining ancient records, searching for evidence of rapid environmental changes that might explain such exceptional preservation. Months later, a new hypothesis begins to emerge. Rather than representing a mysterious object trapped inside the ice, the discovery may be the final remnant of an entire ecosystem that disappeared during the dramatic climate shifts marking the end of the last ice age. If true, the fragments beneath Greenland are not isolated curiosities. They are survivors from a biological world that vanished long before the first human civilizations appeared. The conclusion excites scientists even more than the mystery itself. Instead of asking whether the fragments belong to something impossible, researchers begin asking a different question. If one hidden ecosystem remained untouched beneath the ice for 12,000 years, how many others are still waiting beneath glaciers across the planet, preserved so perfectly that modern science has simply never looked deeply enough to find them?